Module 15, IP static routing. So in this module, okay, it will tell you how to configure IPv4 and IPv6 as a static routes. So subtopic for this module, we got static route, configure IP static route, configure IP default static, configure floating static routes, and configure static host routes. Okay, 15.1 static route. Type of static route. Static route are commonly implemented on a network. This is true even when there is a dynamic routing protocol configured. Static route can be configured for IPv4 and IPv6. Both protocols support the following type of static routes: standard static route, default, floating, and also summary static route. Static route are configured using the IP route and also IPv6 route global configuration command. So next hop option. When configuring a static route, the next hop can be identified by an IP address, exit interface, or both. How the destination is specified creates one of the three following types of static route. So next hop route, only the next hop IP address is specified. For the direct connected static route, only the router exit interface is specified. For the fully specified static route, the next hop IP address and exit interface are specified. So IPv4 static route command. If a static routes are configured using the following global configuration command, this one, yeah. So either the IP address exit interface INTP or the IP address and exit interface parameter must be configured. So for the IPv6 static route, configure using the following command. So this, yeah. So this is command started from here, IPv6 route and all the contents. Most of the parameters are identical to the IPv4 version of the command. So dual stack topology. The figure shows a dual stack network topology. Currently, no static route are configured for either IPv4 and IPv6. So IPv4 starting routing tables. Each router has entry only for directly connected network and associated local addresses. R1 can ping R2 but cannot ping the R3 line. Yeah. So IPv6 starting routing table. Each router has entries only for directly connected network and associated local addresses. R1 can ping R2 but cannot ping R3. Okay. Configure IP static routes. So IPv4 next hop static route. In the next hop static route, only the next hop IP address is specified. The exit interface is derived from the next hop. For example, 3 next hop IPv4 static route are configured on R1 using the IP address of the next hop R2. Okay, like this example. The resulting routing table entry for R1. Okay, we use this to show all the detail. All right. Okay. So IPv6 next hop static route. The command to configure R1 with IPv6 static routes to the 3 remote networks are as follows. Okay. So IPv6 unicast routing. Then next, IPv6 root, this IP and this, and also this, and also this IP. So the root table for R1 now has roots to the 3 remote IPv6 table. Okay. So IPv4 directly connected static root. When configuring a static root, another option is to use the exit interface to specify the 3 directional connected IPv4 static root are configured on R1 using the exit interface. Notes using a next hop address is generally recommended. Directly connected static root should only be used with point-to-point serial interface. Okay, so this is the settings and this is the verification of the setting. Okay, IPv4 directly connected static root. In example 3, direct connected IPv6 static root are configured on R1 using the exit interface. Yeah. So not using a next hop address is generally recommended. Directly connected static root should only be used with point-to-point serial interfaces. Okay, this one. Okay, IPv4 fully specified static root. In a fully specified static root, both the exit and the next hop IP address are specified. The form of static is used when the exit interface is a multi-access interface and it is necessary to explicitly identify the next hop. So the next hop must be directly connected to the specified exit interface. Using an exit interface is optional. However, it is necessary to use a next hop address. It is recommended that when the exit interface is an Ethernet network, that the static root includes a next hop address. You can also use a fully specified static root that includes both the exit interface and the next hop address. IPv6 fully specified static root. In a fully specified static root, both the exit interface and the next hop IPv6 address are specified. There is a situation in IPv6 when a fully specified static root must be same. Yeah. Sorry, must be used. If the IPv6 static root use IPv6 link local address as the next hop address, you use a fully specified static root. The figure shows an example of a fully specified IPv6 static root using an IPv6 link local address as the next hop address. Okay, the reason a fully specified static root must be used is because IPv6 link local addresses are not contained in the IPv6 routing table. Link local addresses are only unique on a given link or network. So the next hop, link local address may be a valid address on my network connected to the router. Therefore, it is necessary that the exit interface be concluded. The following example shows the IPv6 routing table entry for this route. Notice that both the next hop link local address and the exit interface are included as well. Yeah. So verify a static root along with the show IP root and show IPv6 root, ping and trace root. Other useful commands to verify static roots, including the following command like show IP root static, show IP root network, and show running config, pipe section IP root. So replace IP with IPv6 for the version of IPv6. 5.3 configured IP default static route. So default static route. A default static route is a static route that matches all packets. A single default route represents any network that is not in the routing table. Routers commonly use a default route that are either configured locally or learned from another router. The default route is used as the gateway of last resort. Default static routes are commonly used when connecting an edge router to a service provider network or a stub router. A router with only one upstream neighbor router. The figure shows a typical default static route scenario. So default static route. If a default static route, the common syntax for IPv4 default static route is similar to any IPv4 static route, except the network address is 000 and the subnet mask also 000. So the 0 for both, for the network address and also for the subnet mask in the route will match any network addresses. So not an IPv4 static route command is commonly referred to as a quad 0 route. So the basic command syntax for IPv4 default route is as follow. Okay. So IPv6 default route, the command syntax for the IPv6 default static route is similar to any IPv6 static route, except that the IPv6 prefix and prefix length is /0, which matches all the routes. So the basic command syntax for IPv6 default static route is as follow. This one. All right. Sorry. Let's configure a default static route. So the example shows an IPv4 default static route configured on R1. With the configuration shown in the example, any packet not matching more specific route entries are forwarded to R2 at 172.16.2.2. Okay, this one. An IPv6 static route is configured in a similar fashion. With this configuration, any packet not matching more specific IPv6 route entries are forwarded at R2 at this IP. Okay, this is the one. Okay, verify a default static route. Okay, the show IP route static command output from R1 display, the content of static route in the routing table. Note asterisk, or star next to the route with the code S, this. The asterisk indicates that this static route is candidate default route, which is why it is selected as the gateway of the last resort. Okay. Notice that the static default route configuration use the /0 mask for IPv4 default routes. Remember that IPv4 subnet mask is a routing table determining determines how many bits must match between the destination IP address of the packet and the route in the routing table. /O/0 mask indicates that none of the bits are required to match, as long as more specific match does not exist. The default static route matches all packet. So this example shows the show IPv6 routing static command output to display the content of the routing table. Notice that the static default route configuration use the /0, this prefix for the IPv6 default routes. Remember the IPv6 prefix length in a routing table determine how many bits must match between the destination IP address of the packet and the route in the routing table. So for this /0 prefix indicate that none of these bits are required to match as long as more specific match does not exist. The default static route matches all packet. Alright. 15.4 configure floating static route. So floating static route. Another type of static route is floating static route. Floating static route are static route that use to provide a backup path to a primary static or dynamic route. The floating static route is only used when the primary route is not available. To accomplish this, the floating static route is configured with the higher administrative distance, AD. Yeah. Higher administrative distance value than a primary route. The administrative distance or AD represents the trustworthiness of route. If multiple path to the destination exists, so that the router will choose the path with the lowest administrative distance, AD. Yeah. So by default, static routes have an administrative distance of 1, making them preferable the route learned from the dynamic routing protocol. So the AD or administrative distance of a static route can be increased to make the route less desirable than that of another static route or a route learned through a dynamic protocol, routing protocol. In this way, the static route floats and it is not used when the route with the better administrative distance is active. So configure IPv4 and IPv6 floating static route. The command to configure default floating IP default route are as follow. So this for both IPv4 and also IPv6. So use this both command, show IP route and show IPv6 route. Yeah. So output verify that the default routes to the R2 are installed in the routing table. Note that IPv4 floating static route to RT is not present the routing table. Okay. Test the floating static routes. What will happen if R2 fail? To simulate this, R2 shut down both of its serial interfaces. Okay, and then R2 automatically generates syslog message for the link going down. So and then A looks what is it? A. So A look at R1 routing table will show the secondary route being used. Okay, I think user look at routing table. Yeah, okay. So 15.5 configure static host routes. Host routes. Host route is an IPv4 address with 32-bit mask or an IP address, IPv6 address with 128 bits mask. The following shows the 3 ways to host route can be added to the routing table. Automatically install when an IP address is configured on the router. Configure as the static route. Yeah. Static host route. Host route automatically obtained through other methods. So it will discuss later courses. Yeah, later courses. Automatically install host routes. Cisco iOS automatically install a host route, also known as a local host route, when an interface address is configured on the route in the router. So a host route allows for a more efficient process for packets that are directly or directed to the router itself rather than for packet forwarding. This is in addition to the connected route designated with a C in the routing table for the network address on the interface. So the local routes are marked with L, capital L, in the output of the routing table. Static host routes. A host route can be manually configure static route to direct traffic to a specific destination device such as the server as shown in the figure. The static route use a destination IP address 255.255.255.255/32 mask for IPv4 host route and /128 prefix length for IPv6 host route. Configure static host route. The example shows the IPv4, IPv6 static route configuration on the branch router to access the server. Yeah, this one. So verify static host routes. A review for both IPv4 and IPv6 route table verify that the route are active. All right, so this one for IPv4, this one for IPv6. Configure IPv6, yeah. Configure IPv6 static host route with the link local next hop. IPv6 static route. So the next hop address can be the link local address of the adjacent router. However, you must specify an interface type and an interface number when using a link local address as the next hop, as shown in the example. First, the original IPv6 static host route is removed, then a fully specified route configured with IPv6 address of the server and also IPv6 link local address of the ISP router. All right. Okay. All right. So module practice. So packet tracer. So in this, you can have this in our NetAcad website. Okay, regarding configuring IPv4, IPv6 static and default routes. In this packet tracer, you will do the following tasks like configure IPv4 static and floating static default route, configure IPv6 static and floating static default route, And next, configure IPv4 static and floating static route to internal LANs. And IPv6, configure IPv6 static and floating static route to the internal, internal LANs. And next, configure IPv4 host route and also IPv6 host route. And you will have a lab session or lab activity also, configure IPv4. This one in fact in NetAcad, IPv4 and IPv6 static and default routes. In this lab, you will complete the following objective: build the network and configure basic device setting. So try to have this, or try it. Configure and verify IP and IPv6 addressing on R1 and R2. And next, after that, configure and verify static and default routing for IPv4 on R1 and R2. And next, finally, configure and verify static for default routing for IPv6 on R1 and also R2. Okay, that's all for this topic. Okay, thank you for listening. See you in the next module.